Renault F1 and Fernando Alonso were dominant in F1 through the mid-2000s, but it wasn't just Fernando's crazy driving style that gave them such pace. The car had a genius mechanical device fitted to the nose of the car that made it extremely stable and gave it much more grip than any of the other cars on the grid. It was an idea that Renault copied from skyscrapers, where they use a large suspended mass to counteract the swaying of the building. They came up with a condensed down version and fitted it to the car. It gained them downforce, made the car much more confidence inspiring through the corners and gained them huge lap time. But how did Renault take something from a skyscraper and use it to make their F1 car so dominant? In 2005, new regulations meant the front wing had to be 50mm higher than in previous years, so the teams often lowered the whole car to get the new wing closer to the ground and therefore be more effective. However, this meant the springs needed to be much stiffer to stop the car bottoming out, which then caused another problem. As the F1 tyres hit bumps or clipped curbs, the car experienced pretty serious vibrations. Typically, this led to the nose pitching up and down around 8 to 10 times a second, completely ruining the airflow over the front wing, leading to a huge reduction in downforce. It also led to the grip levels changing through the corner, making the car very unpredictable and difficult for the drivers to drive at the limit. So Renault developed a tuned mass damper for the 2005 season. This was a device that would oppose any up and down vibrations, making the car more drivable and improving grip. So how did it work? When you have a mass on a spring, then pull it, it oscillates. But let's say you do this with two masses and two springs, and something weird happens. They appear to take turns, with one oscillating and then the other. One takes energy from the other, then passes it back. This is the concept that is used in the Taipei 101 skyscraper. It has an enormous mass damper that counteracts the natural sway of the building, even protecting from 130-mile-an-hour winds and huge earthquakes. The 660-ton mass is suspended with huge steel wires, meaning it can move independently from the building. This concept is the same as the two masses on the springs. It means the building passes its swaying energy onto the pendulum, which is then gently damped, removing this energy and reducing the swaying. It's also tuned, meaning the springs and the mass are specifically chosen so they have the same natural frequency as the building. This means that when the building sways one way, the mass moves in exactly the opposite direction, always opposing the movement of the building and reducing the sway in high winds. So how do you go about fitting one of these to a Formula 1 car? Firstly, Renault's vibrations were in the up and down direction rather than side to side, so they came up with a different design but used the same concept. It consisted of a donut-shaped mass originally at 10 kilograms that sat in a cylinder. It had a spring on either side that suspended it, so whenever the car went over a bump, the mass would move up and the springs would push it back to the centre. However, the really clever bit was how they designed the mass and the cylinder to fit together. They had a very small but precisely designed gap between the airtight cylinder and the outer edge of the mass. This damped the system. Every time the mass moved, the air squeezed around the edge. This dissipated some of the energy, which in turn reduced the vibration of the car. So how did it make the car faster? Thank you so much to everyone who helped us get over 400,000 subscribers last week. It's absolutely incredible, but 85% of you still aren't subscribed, and we'd love for you to join us. As a driver, you're always predicting the grip at any one corner, estimating how much speed you can carry and how much cornering force the car can take without going over the limit. So you're always going to be quicker, more confident and more refined in a more drivable car. And by that I mean a car that reacts the same every time you hit the brake pedal, turn it into the corner or hit the accelerator. The vibration in the 2005 F1 cars meant that the grip level wasn't consistent. Let me explain. We know that one of the factors that affects how much grip a tyre has is how much force is pushing it down into the track. That's why we like downforce. But if the car is oscillating up and down, this downward force is changing. This really matters. It not only changes how much the rubber is pressed into the road, but also the size of the contact patch on the tyre. Because the harder it's pressed into the track, the more the tyre deforms, making the area of the tyre touching the road larger. Let's say that as Fernando went through a fast right-hander like Stowe, the front left tyre is experiencing 500 kilograms of downward force. This would mean that the tyre would provide a certain amount of grip, and Fernando would anticipate this and be driving just on the limit, extracting the most speed from the car. But in an unpredictable oscillating car, this downward force changes 8 times a second throughout the corner, perhaps fluctuating between around 400 and 600 kilograms of downward force. This means that the grip level isn't consistent, so the driver would have to back off to be sure the car would stick. This is where the tuned mass damper comes in. Whenever the car moved upwards, the mass moved the opposite way, pulling the car back towards its normal ride height. This made the car very stable, keeping the grip consistent, and Alonso said it gave him massive confidence through the corners. It also performed well over curbs, allowing him to hit them harder and find more lap time. Often with chicanes, you're balancing taking more curb and having a better racing line, with not disrupting the car too much on the exit. Fernando could take a much better racing line and not risk jumping off the curb and ruining his exit. Renault began testing the car on their 7-poster rig before every race. This is a testing rig that is normally used to choose the correct suspension settings for each track. They discovered they could tweak the springs and the mass in the system to optimize it for things like bumpier tracks or compensate for larger curbs. Although the system was mechanical and aided the suspension system in the car, it gave additional benefits too. It allowed Renault to run with the lower ride height and stiffer springs, gaining them downforce and lots of lap time. Renault estimated that the tuned mass damper gained them between 2 and 4 tenths of a second per lap, depending on the circuit, normally gaining most on the bumpier tracks. As ever, the majority of the other teams copied the system, but there is always a lag between the introduction of new technology and all of the teams getting it working to its full potential. So Renault took the Constructors' World Championship in both 2005 and 2006, with Fernando taking both drivers' titles. The mass damper system, despite being approved by the FIA in 2005, was banned for the 2007 season, as it was deemed a movable aerodynamic device. Renault appealed this for obvious reasons. The damper is as much of a movable aero device as the suspension of the car, but the ruling stood and they weren't used for the 2007 season. I analysed the absolutely bizarre driving style that won Alonso his 2 titles in this video. I break down what makes him so successful and why it's so different to what anyone else does. Please do consider subscribing and I'll see you in the next one.
Is this going to be the pole of the moment for Fernando Alonso? It is. He lost a little bit with that mistake in the final corner, but nevertheless it puts him top of the timesheets.